In this video, we are going to simulate half-wave rectifier controlled by thyristor. This is the question. Design, simulate and analyze single-phase half-wave rectifier controlled by SCR or thyristor with the following details. The details are maximum voltage is 100, frequency is 50 Hz, resistance is equal to 1 ohm, phase delay or delay angle of the thyristor is 45 degree. So after analyzing the simulated output, draw various simulated waveforms on the graph sheet. Change the value of resistance to 2 ohm. Simulate and draw the current waveform on the graph sheet. Change the firing angle to 90 degree. Simulate and draw the output voltage and current waveform on the graph sheet. Write your inference. So this is the question. So first we are going to simulate with the delay angle of 45 degree, and later we are going to change it to 90 degree. Similarly, first the resistance will be 1 ohm, and later we are going to convert the resistance to 2 ohm, and then we are going to observe the current waveform, and we have to record our inference. This is MATLAB's home page. Here we are going to click new Simulink model. Let's open a blank model. Maximize. Let's open the library browser. Okay. Either we can drag and drop from the library browser, or you can just double click in the space and then type AC voltage source. So this is AC voltage source. Next we need thyristor. So this is thyristor. Next we need series RLC branch. Series RLC branch. Control R. Double click series RLC branch and select the branch type as resistive load. So let's connect the supply to anode, then cathode to the resistor, and the resistor back to the supply. Let's double click the thyristor and disable this show measurement port. Apply. Okay, this is for simplicity. Double click AC voltage source. Here the maximum voltage or peak amplitude is 100. That is what we want. But the frequency should be 50 Hz. So change 60 to 50. Okay. Then this is thyristor. So we have to give gate pulse. So for that, let's choose the pulse generator, and let's connect the pulse generator to the gate. Double click pulse generator and let's do the settings. Amplitude is 1. Period. The total time period is 1 by 50, that is 0.02 seconds. So time period in seconds. Pulse width. Let's choose the pulse width as 10%. Then phase delay in terms of seconds. So phase delay in terms of seconds. So we have to give 45 degree phase delay. Therefore 45 divided by 360. Okay. 45 divided by 360. Then multiply by, since we need to convert it into seconds, it will be 1 divided by 50. 50 Hertz. 1 by 50 is the total time period. Right. So we can write like this, or else we can simply write 45 divided by 50 into 360. Okay, so apply. Okay, so gate pulse is given at the delay angle of 45 degree. Next, double click resistor, it is 1 ohm. So okay, so we have done the connections. We need to measure the supply voltage, we need to measure the voltage across the resistor, then we need to measure the current. Therefore we need voltage measurement block. Voltage measurement block. So this voltage measurement blocks measures the voltage, supply voltage. Right click and drag so that we will get another voltage measurement block. So this is going to measure the voltage across the load. Then we need a current measurement block. Current measurement block. This current measurement should be connected in series. So let's remove this branch. Let's connect in series. Now we need to see the voltage, current and the pulse given in the circuit. So we need scope. SCOPE, scope. Scope is there. We are going to measure four things. One is supply voltage 1. Number 2 is the gate pulse. Number 3 is output voltage. Number 4 is output current. So I'm going to double click the scope. Go to configuration parameters. Number of input ports should be 4. Next, layout. Layout 4. Apply. Okay. So I now I can see 4 scopes here. So first I am going to give the supply voltage. Second I am going to give the gate pulse. Third one is the output voltage. Fourth one is the output current. Then I need power power GUI. Power GUI for simulating this one. Change the continuous to discrete. Apply. Okay. Change the stop time to 0.1. 0.1. 0.1 means we can see 5 cycles because one cycle is 0.02, then 5 cycles means 0.1. So stop time is 0.1. Now I am going to run the simulation. Run. So it is compiling. It is finished. So now I am going to double click the scope. Maximize. The first one is the supply voltage which is sine wave. Second one is the gate pulse. 10 percentage gate pulse, 10 percentage pulse width. Then at a delay angle of 45 degree. So this is the output voltage and this is the output current. So output voltage and output current are same and the magnitude is 100. Since the load is resistive, both are same. So in the question, they have asked to change the value of resistance to 2 ohm. So the value of resistance 1 ohm to 2 ohm. I am going to convert 1 ohm to 2 ohm. Click OK. Now run the simulation. Let's observe the readings. So here you can see voltage, the magnitude of the voltage is 100, whereas the magnitude of the current waveform is 50. Why? Because we have changed the resistance value to 2. Therefore, the current value has been decreased. The magnitude of the current waveform is decreased. And in the question, the pulse width. Next, we have to change the firing angle or delay angle to 90 degree. 90 degree. So here we have used 45 degree. Now I am going to change it to 90 degree. 90 degree. apply, OK. Now run the simulation, double click the scope. It is not externally used simulation time. Apply, OK. Run, double click, OK. Now you can see supply voltage, firing angle is at 90 degree. So the output waveform is changed to 90 degree, and this is output current. So this is the waveform we want.